Since I was given some racket kits one year for my birthday, I've been wanting to join two Baby 8s to make a 16-step sequencer. I've returned to this project a number of times, but never really got out of the starting gate. Yes, there are one or two published projects, but part of the enjoyment of this for me is to work out how to do it myself from scratch. Initially, I attempted to use Logic to direct 8 clock signals into one and then 8 into the other, but then hit on the idea of running them in parallel, offsetting them by inverting the original clock signal. This has the added advantage that it would be possible to swing the rhythm by adjusting the duty cycle of the original clock signal. This is the furthest I've got with it so far. It makes an eye-catching and ear-splitting demo, but there are still too many problems to solve, some that I had predicted and some that I have discovered along the way. None of the challenges are unsurmountable, but it requires more analogue electronics than I'm comfortable with, and it started to feel as if I'd be building so much stuff around the Baby 8s that I could have started from scratch in the first place. This led to me sketching out something of my own. Me being me, this idea is microcontroller driven, with as much functionality as possible done in software rather than hardware. Doing this with a microcontroller opens up a world of possibilities. We don't have to be limited to 16 steps. For example, we could have A and B patterns as alternative, switchable 16-step programs, or run sequentially to make 32 steps. The ability to store and recall patterns. Some of these ideas helped to make my decision on lit tactile switches versus physical switches for skipping steps. The ability to lock the output to a certain scale or mode. A swing rhythm with adjustable swing as an alternative to straight 8s. Like Ether, the ability to generate MIDI as well as analogue output. Adding a small screen and encoder like MIDI-SID to help with selecting advanced features. The first challenge with this project is the large number of analogue and digital inputs and outputs, and I think I've got that sorted. I've got 2 analogue pots operating the tempo and the duty cycle of the gate. I'm also using an analogue mux to read currently 4 pots, but there's capacity here to expand that to 16. I just haven't got the pots today, or the inclination to wire them all up. 23017 port expanders will help with the digital I/O. You're not hearing anything here because I haven't yet settled on how to generate an accurate volt per octave control voltage from a 3.3 volt microcontroller. And I do want it to be accurate. That's the next piece in this puzzle, and I have 2 ideas which I will try out in the next few days to see which works best.